How do wings really produce lift? Why does an airfoil moving forward result in a net force upwards on that airfoil? There's a lift theory you've likely heard and maybe even stated yourself. The curved surface over the top of the wing, the camber, has to move faster to reach the airflow over the flat bottom of the wing. Because of this difference in the flow speed of air, Bernoulli's principle tells us that there is a lower pressure on the top surface of the wing than there is on the bottom. Consequently, there is a net force upwards, lift. This sounds very smart and accurate. There's a tiny issue with it though. It's completely wrong. Air molecules floating over the top aren't trying to catch up with their buddies at the bottom. In fact, flow is completely separated until air molecules hit the leading edge. There is no catching up or equal transit time. Also, relatively flat wings can fly perfectly fine, though it's just a little bit more optimal to have that curved surface. With this video, you'll hopefully understand why the equal transit time theory is a fundamentally wrong explanation for the technically valid pressure dynamics in Bernoulli's principle and Newtonian mechanics. Now, the first thing you have to understand is that air molecules are not trying to reunite at the leading edge like the Romeo and Juliet or long lost lovers or anything. I mean, just take a look at this.
If we now slow the video down, you can follow those lines, and that gives you an idea of how fast the flow is in different parts of the airflow. Here you can see it speed up as it approaches the airfoil, and it moves faster over the top compared to the bottom. You can see that it reaches the end on the upper surface much earlier than it does on the lower surface. In fact, by the time it reaches the end on the lower surface, the flow has already gone a long way past on the upper surface. This shows very clearly that the flow doesn't take the same amount of time to reach the end of the wing.
Airflow over the top clearly does not care about airflow over the bottom. Yes, air is moving faster over the top and slower over the bottom, but that is due to pressure differentials, not the other way around. Let me explain. In reality, it is a wing's angle of attack, not the curved surface over the top, that does most of the heavy lifting. Because air is moving towards the wing, if we were still relative to a forward-moving airfoil, and the wing is at an angle attack relative to the airflow, air essentially gets smacked into the bottom surface. This creates a higher pressure zone at the bottom of the wing as there are more air molecules moving slower. And number two, it creates a downwash of air molecules. And downwash is basically when that air moving over the bottom, and even some over the top, once they reach that leading edge, they essentially get pushed down. Right? So because they get pushed down, there's a reaction force upwards, which is lift. As the wing moves through the air, it leaves air behind it and smacks into oncoming air. So basically this creates a pressure difference. There's low pressure here, you're leaving air behind, and high pressure here, you're smacking into air. This pressure difference is what causes air to speed up over the top and slow down at the bottom, not the other way around. Also note that airflow on the top and bottom of the wing are independent of each other until they meet at the trailing edge and downwash away from the airfoil. In other words, it's the wing's angle of attack that creates a pressure difference, which then accelerates air and creates a difference in between flow speeds over the top and flow speeds over the bottom. Both Bernoulli's pressure dynamics and Newtonian mechanics help explain lift, and neither have anything to do with equal transit time, right? Flow over the top of the wing does not care when flow over the bottom of the wing reaches it. It's not gonna accelerate to try and catch up with it. The net result of integrating the area of the wing and the pressure differentials with lower on the top and higher on the bottom is a net force upwards. That's lift. Moreover, the downwash caused by smacking into air at an angle of attack also creates a change in the airfoil's momentum, which also pushes the aircraft upwards. However, what you need to know right now is that Bernoulli's pressure dynamics and Newtonian mechanics are at the heart of real aircraft lift. Nothing here has to do with air over the top of the wing having to reach the leading edge at the same time as air over the bottom of the wing. They do not care about each other. There are established pressure differentials which accelerates air over the top of the wing than air over the bottom of the wing, not the other way around. By now, you hopefully understand that equal transit time theory is just plain wrong. Instead, if anyone asks, you'll explain to them that the angle of attack of the wing creates a pressure differential, which then accelerates air over the top of the wing compared to over the bottom of the wing. Currently, I'm working on a video explaining how propellers are really just rotating wings, so make sure to subscribe to see when that comes out. For now, just leave a like if you took something from this myth-busting episode. Also, go watch my explanation on how the sonic boom works.